All right, the key ideas that we picked up from the day before was when you're dealing with the inverse trig functions, you have the inverse sign. When you're dealing with the inverse sign, we have two general equations. When you're talking about the two general equations, we have theta is equal to the principal value. Okay, the principal value, and the principal value is, how do we get the principal value? How do we get the principal value? Yeah, your calculator. Principal value is your calculator value. So you have your principal value plus or minus the period n, which in our case right now, that is 360 degrees. When we get to Monday, we'll change our equation around a little bit, and the period will be a little bit different. We'll have to calculate the period like we did before. 360 divided by b, or 2 pi divided by b. The second value, second equation, comes from the supplement. The supplement to the principal value plus or minus the period n. When we deal with the inverse cosine, our first equation, once again, is our principal value plus or minus the period n. And then the second equation comes from the opposite of the principal value plus or minus the period n. These will be the same general guidelines and general cues that we will use throughout this entire section, this entire chapter, okay, or dealing with the principal values. Now, today we're going to start throwing a few little monkey wrenches in there. Not really monkey wrenches, but some different aspects of it. Because now I'm going to throw the variable x at you. Which means if I throw the variable x at you, what mode do we have to put our calculator into now? Radians. Okay, we need to be dealing with radians. When you deal with x, you're going to have to go into your radian mode. So let's go and put your calculator into radian mode. But the same method of madness and the same philosophy and the same cues are going to be still with us. We're going to look for two general equations and the first three positive solutions. But now we're dealing with x here, not theta. Okay, when dealing with the inverse cosine, what we just talked about, inverse cosine, the first value we come up with is our principal value, calculated value. So I can clickety-clack through inverse cosine, 0.73. Take it to two decimal places. What do you get? 0.75. Okay, yes, no, maybe so. We'll go with that. Plus or minus the period n. Now, we've now just changed to the idea of radians. Yesterday, we were in theta, we had plus or minus 360 n. Now we're dealing with radians. What's 360 in radians, Brady? 2 pi. So we are plus or minus 2 pi n. Same method of madness. We just have to change our mental thought to, I'm no longer in theta in degrees, so I no longer have 360 degrees. I'm now in x in radians, so 360 degrees, the period is going to be now 2 pi. Second general solution, inverse cosine. How do we find our second general solution? Inverse cosine. How do we get the second value? Now, what did we just talk about here? Inverse cosine. Get the principal value plus or minus period n. Second one comes from what? Inverse cosine. Just went through it.
0.751.
Yeah, 0.75, that's our principal value. How do we get the second one?
Add 2 pi.
Now, what did we just do? What did I just write up here? What did we just go through? Maybe you should write things down as we go along, because I write things down for a purpose. I don't write things down just to listen to myself speak and talk and watch my own handwriting up there. How do we find the second value? The opposite. We look at the opposite. So we have the opposite, negative 0.75 plus or minus 2 pi n. First three positives. Pi, once again, if I put 180 degrees in for pi, I'm now going back into the degree mode. I don't want to go into the degree mode. I want to stay in the radian mode. So my pi here is 3.14. If I multiply that by 2, 6.28. So I'm going to either add or subtract 6.28. Okay, so I want my first three smallest positive values. So I'm small here. If I subtract, I'm going to go into the negative world. If I add negative 0.7 to 6.28, I'm going to go sort of biggish. So my first positive value, 0.75. Now to find my second value, I can take my negative 0.75, add 6.28. That's why I tell you to go 2 decimal places with radians. Because I'm going to use the 6.28. So if I go 2 decimal places with my values that I come up with my calculator, I can then use 6.28. I have the same number of decimal places. What do we have for the second value, Jacob? 3.89. You have negative 0.75 plus 6.28. Negative 0.75 plus 6.28. You're adding 3.14 to it. We have 2 times 3.14. 5.53. Then to go from 1 to 3, we can leapfrog. What do we add to 1 to get to 3? Grayson? 2 pi. 6.28. So we can add 6.28 here. Add the period, which is 6.28. What do you come up with? 7.03. Now, in the radian mode, I want you to take the cosine of 7.03. Do we get something close to 0.73? All right, so we're close. We're close. All right, inverse sine. I'm still in the next world, so I'm still in radian mode. First value, clickety-clack, clickety-clack. Pull out of my calculator. What do we come up with, Adam? 1.25 plus or minus 2 pi n. Once again, this is still your principal value. Now we're going to look for the second value. To find the second value, what do we have to come up with our second value? Micah? The supplement. So let's take a look. Let's go back and let's go back to degree mode just for a second here. No, you don't have to. You don't have to. In your mind. in your mind, let's go to the degree mode. If theta was 40 degrees, theta was 40 degrees, what would be the supplement to 40 degrees? Sophia? 140. How'd you get it?
Subtracted 180 from 40.
Okay, so you want 180 minus 40. Okay. What if I had 137 degrees? What would be the supplement to 137 degrees? Nick? $43. How'd you get it? 180 minus 137. If I had negative 10 degrees, what would be the supplement to negative 10 degrees? Alec? 190. And I can follow the same method of madness. I can take the 180 minus the negative 110 to give me a negative 1 or a positive 190. All right. Let's now change our world to x. If my x is 1.25, I'm now in the radian world. What should we do to find the supplement in the radian world to 1.25? Because in the radian world, this 3.14, this is the value of pi, which corresponds to what we did here. We subtracted from 180 in each one of these situations. Well, what's 180 in the radian world? 180 is the value of pi, 3.14. Once again, the reason why I'm telling you to go to 2 decimal places. So I have 3.14 minus 1.25. So our second general equation will be what, no?
1.89.
Plus or minus
2 pi.
2 pi n. First three positives. Okay, if I subtract this 6.28 from both of these, I'm going to throw myself into the negative world. Okay, 1.25 minus that, 1.89 minus that, I'm going to go negative. So I don't need to subtract anything. But so I can look at these two values for my first two positives. 1.25, 1.89. Then to go from 1 to 3 to play our leapfrog, what are we going to add to 1 to go to 3? And what we're going to add to 1 to get to 3? 6.28. We add the period, 6.28. So what do we come up with? 7.53. 53. So if I would take the sign, okay, in your calculator, take the sign as 7.53. Do I get something close to 0.95? Yeah, I'm close. Not exact, but close. So what we have to now take a look at, when we're in degrees, we have our thetas in there. But when I have x, now we have to switch to the radian idea. right now, the period is 2 pi rather than 360 degrees. Okay, once again, that's going to change once we get to Monday, and I'm going to get you a little bit more involved equation. How we find the supplement? We have pi, or 3.14, minus the principal value. Rather than 180 minus the principal value, it's now pi minus the principal value. All right. Let's find the two general solutions and the first three smallest positive values. Okay, write your general solutions. Once again, go to two decimal places. Then your first three smallest positive values. Just do the first one. Check your answer with somebody around you. All right, James, what do you have? General solution, what's your first one?
X equals 0.66 plus minus 2 pi.
Okay, and then the second one?
2.48 plus minus 2 pi.
And once again, to find the 2.48, this is our supplement. 3.14 minus the 0.66. Now, if you have 0.67, okay, somebody have 0.67 in there or not? Yeah. Okay. If you round, usually you're going to round up to around to the nearest two decimal places. This changes to a 7 here. This changes to a 7 here. That is fine. Once again, I'm not going to nickel and dime you about a penny. Okay, if you have 0.66 or 0.67, I'm not going to sit there and round correctly. At that point, if you've gone through this process, did everything correctly, I'm good with that. Okay, first three positives. What do you have for first three positives then?
0.66, 2.48, 6.9.
6 point what?
9.4.
And once again, if you have 7 here, this is 7 here, then this would be 5. All right, so it's fine. Look at the second one. Inverse cosine, 0.378. Once again, you need to evaluate. First off, notice I am still in X, so I'm still in radians. Okay, get your two general solutions and your first three positives. Check your answer with somebody around you.
Oh, shoot. Cosine. I got you. I did get a sign. Yeah, I didn't realize when I pointed at
All right, general solutions. Tomorrow, what do you have for the general solutions? 1 point what? Plus or minus? And second one? All right, first three positives. Jacob, what do you have for the first three positives?
1.18, 5.1, and 7.46.
And once again, we have to take the 6.28 and add the negative 1.18 to that to be able to get the 5.1 here. 7.46, we play leapfrog to go from 1 to 3. We add the period, which in this case is 6.28. And as we done before, if we take the cosine in our radian mode, 7.48, you should get something very close to 3.378. On page 81. Page 81. You have the 3 to 39 multiple of 3. Now, what you have to pay attention to when you're going through the problems. You have 3 to 39 multiple of 3, so you go number 3. The variable you have in problem number 3 is theta, which means what mode your calculator has to be in? Degrees. Problem number 6, you're in x, so you need to go back to radians. So you need to pay attention. The first half of all the problems are in theta degrees. The second half of the problems in each section are in x radians. Okay. Now, when you get down to the bottom, problems number 33, 36, 39, if you keep it in a degree mode, that's fine because you're going to get multiples of 30, 60, or 45. Because they're going to ask you to do things in terms of pi. So that's one of those things, if they're going to ask you to keep things in terms of pi, keep it in a degree mode. So when you come down to 150 degrees, you can then convert that to 5 pi over 6. Or if you come down to 60 degrees, you can go to pi over 3. It's a little bit easier for you. Okay, so down in the bottom, 33, 36, 39, keep it in a degree mode when you're doing your degrees, or when you're doing your degree, or what the radian measure is in terms of pi. All right, questions you have? Okay, the first 3 and 6, you're just doing the principal value, which is just your calculator value. 9, 12, 15, 18, 21, 24. Now you're doing what we did there. Okay, then 24, 27, 30 down the bottom, you're just doing the principal values again. All right, first time is yours.